Thank you very much, and it is truly, truly a pleasure to be here and not be talking into my camera and my laptop and talking to my dog. So thank you once again for coming out here. So today we're going to be talking about APIs. They're a potential vulnerability that a lot of organizations really need to take seriously. Ultimately, one of the biggest things that we've seen over the last few years is that while APIs have really been around for a very long time, used very, very commonly, the proliferation and the increase in them has really made it much more of a security threat and concern than we've historically seen in the past. So first we'll go into some of the reasons why this is. So when you go out and you talk to different people across an organization, if you talk to the business teams, they're going to tell you that they're using APIs to be able to transfer data back and forth between other business units or some of their customers. If you go talk to your back-end developers are going to tell you we're moving to microservices and we're deploying all the new fancy cloud-native architectures. And the way that those APIs or the way those services will communicate to each other or with each other is going to be via APIs. If you go talk to your front-end developers or your mobile developers, they'll say, we're using APIs for front-end single-page applications, we're using it for our mobile apps, we're using it for IoT and connected devices, and they're right as well. And then if you go talk to your DevOps team, they're going to say, well, we're using APIs for pretty much everything. If they're using Terraform, ultimately, that's interfacing with APIs underneath the hood. If they're using CDKs and all the other technologies that DevOps teams love talking about, ultimately, APIs are the lifeblood. And so all of these people are 100% correct, and this is really where the focal point of it comes into, is now we look at this and we say, this is a massive attack surface now that is only getting larger. So what I mean by that in specifics is when we went out and surveyed organizations, what we quickly found was for every organization that we talked to, they had a minimum of at least 300 different APIs. These are basically they're prolific, they're everywhere. 80% of businesses that we talk to are building, deploying, and this is kind of the common way that they're developing new services. Now, as we go forward and we talk to the security team, you get a slightly different picture on the state of things. While the business team is running ahead and doing these things and they're building it full bore, the security team is lagging behind in terms of their visibility into what's actually being done. They'll see that new resources are coming online, they'll see that new APIs are there, but they won't know the details of them. They won't really know what's really under the hood, and that's where some of the challenges are, is when you get into the weeds behind them. Above and beyond that, the technology ecosystem is complex. Anyone that's ever gone and seen the Cloud Native Computing Foundation and their landscape of technologies that you can use and just the eyesore, there's more products and solutions on there than there are vendors here. It's really, really a challenge to be able to keep up with everything. Now, your app teams, they might have their own specific API gateways that they use based on their technology. They could use AWS's API gateway or Apache or any of the other hundreds of them that are out there, basically depending on their use cases. And more than anything above and beyond that, we also have integrations with third-party APIs. Sometimes, depending on the business context, some of these might be metered. You might be paying for every single API request that you have. And so these can also be costly in certain instances if they don't have certain protections over it, or it can be exposing certain types of data types that you don't expect. So to give you an example here of just how things have changed a little bit more, as we go into and we look at a pretty common use case from a vulnerability for an API, what we have here is we basically have an attacker that can go and basically analyze the API structure. It's pretty easy for them to do this. They can either go pull a Swagger specification and look what's published, or they can go in and they can just enumerate the API and kind of figure out things. If it's a RESTful API, it has a fairly predictable call structure for how it works. If it's a GraphQL API, they can just go and look up the actual schema itself for it. Now, ultimately, if we see a request and this one's getting user details with a specific ID that's passed into it, everything checks out. API gateway says this is a valid request. The API schema protection, if you're protecting and conforming against the schema, everything says, yep, this is great, pass it along. Now, where we get into issues, though, is when we get into kind of hairier security challenges like authorization. So in this particular instance, we basically are still saying, well, hey, give me this user's data, but the application has a really poor authorization framework, and they're basically returning this data back. So now, this is a pretty old problem in security AppSec domain. Anyone that's been doing AppSec for a really long time, you'll know this is called IDOR, or Insecure Direct Object Reference, at least as it was formerly called. But now with API-specific events, we call it broken object level authorization. And ultimately, the reason for this is because With APIs, the guessability, the enumerability of the APIs by design ultimately made this a much more impactful vulnerability. It's very easy for you to go in, enumerate APIs, and effectively exfiltrate data. Now, when you ask application teams to go and fix this or do things, every single application team just comes up with their own solution, and that's kind of the way forward. Now, as we look at then all of the other vulnerabilities that basically come across for APIs, what I always like to do is think about things in really two different categories. So the first one is, if you have a known vulnerability, something that is basically following a very well-known attack pattern, and a great example here, of course, was like Log4j, but Struts before it, or any of the other vulnerabilities that basically have come out in the past, they have very specific payloads that are executing in there. They're very predictable. Now, signatures always get a bad rap in the security industry, but there's a reason why we still use them, is because they're effective against these types of attack vectors. Ultimately, yeah, there's permutations, there's encoding attacks that can be done to try to obfuscate the payloads, but at the same time, it is a very effective mitigation for those. The second type of attack vector, though, is when it becomes more application specific. So that previous example that I just gave you there is a great example of this. There was nothing inherently wrong with that request. In the context of one application, that might have been a valid request where you can get one user's data and then request another user's data, and that's totally fine. In an insurance application, you don't want to do that. So the business context is really where it comes into that this becomes extremely valuable, and there's no way for you to be able to just write a one lump sum signature that can basically correct across all of these different use cases. And so this is where, as we think about building out API security strategies, first where you need to go. So what I always tell people is, when you're looking at API security at the highest level, first of all, take your existing security strategy that you have for application security and start there. So all of these items here that are in pink, these are effectively mostly rehashes of things that showed up in other OWASP top 10 frameworks, the ones that were more specifically related to web applications. The names have changed a little bit, but by and large, there are well-known techniques to be able to defend against them. And most importantly, when you really kind of think about them, the different types of vulnerabilities here are not really application specific. They don't really care what the APIs are on the back of the behind it. Log4j vulnerability didn't care what type of API it was. It just cared whether or not it was Java and running Log4j. So to mitigate these types of things, we have, and there are plenty of existing technologies that will do a great job at being able to mitigate this and basically cascading downwards. So mitigating DDoS attacks at the edge, using bot protection technologies to be able to identify and classify bots, whether it's to a web application, mobile application, or just an API itself. And then getting into more things like credential abuse. So account takeover is a pretty common attack vector that anyone that has a login page has had to deal with. And of course, the known attack patterns. These are the things like Log4j, where they have CVEs that are associated with them. And ultimately, at the end of the day, you can mitigate those using technologies like web application firewalls. Now, the ones in blue, the 4 that's over here, so 60% of your strategy, pretty much reusable. The other 40%, that's where things get trickier. And that's where ultimately we have to look towards API security specific solutions to come in and fill the gaps. So there's a couple ways that we do that. First and foremost, you have to understand the API. You've got to be able to get in there and actually understand the business context of what it's actually doing. Now, we love talking about shifting left and not slowing down the development process and things like that. It's easier said than done. Now, there are strategies, though, that you can use to be able to get there. So the first thing is starting with discovery. So one of the big things that we always find is if you go to talk to application developers and you say, hey, let me have your Swagger specification, you'll get one of two responses. You'll either get what's Swagger, or we don't have one, we didn't write one because the API is old and it's really time consuming to write that. Or they'll say, hey, we've got this specification here it is. And then inevitably what the development or the security team ends up doing is they find, well, that Swagger specification was only about 80% complete, if they're lucky. There's a lot of stuff that's in there that basically they didn't expect actually made its way into production, or old APIs that they thought were deprecated, but turns out they're still alive. And so what we always say for doing discovery is really starting at the end. So you'll see here kind of the way that this is structured is at the very end. We always talk about shifting left as being kind of the panacea of basically security and everything about it. And what I always say is, yeah, it's a great idea and it's something that we want to do, but at the same time, tell yourselves what's actually running in production. We've had developers that swear up and down that their spec is 100% accurate and is the only thing that's running in production, and then we go and discover and watch what their APIs are doing in production, and we find a dozen endpoints that they didn't have documented. And it's just the nature of things. And so what we always say is trust but verify, and so we're going to go and monitor in production. So we discover all of the APIs, and as you think about discovery, there's a couple of different things you want to know. When you're talking about things like RESTful APIs, the first starting point is just knowing what are all the endpoints that are out there. So I want to know basically whether we have the various, all of the get/user, post/user, put/user, endpoints, methods, everything that's part of it. That's really the first step. The second step is then getting into the payloads itself. On the payload side of the conversation, you've really got two different aspects that you need to look for. The first is the request. So you need to know what your customers are basically sending you. This is a great spot where you're doing the specification validation. You're making sure that things are actually conforming to the way the APIs are designed to actually behave. One of the things I always do when I talk to developers is effectively, there's that old development saying where you want to use design by contract for your APIs. Your API specifications, the interfaces themselves are effectively a contract that you've made with other developers, and you agree not to break that contract, they agree not to break it in that way. And that's exactly the mentality that you want to take with your externally facing APIs in terms of validation of it. Now, the other side of that equation is you have the request, but you also have the response data. Well, as a security team, you don't necessarily need to worry about the validation of responses and what's going back, but there's one really key thing that you really need to look for in there. Is your application development team accidentally sending sensitive data back in the responses? We've had a number of instances that we've seen over the years, very, very public API breaches that have happened, where the development team rolled out an API and everything really looked good, and they were exposing maybe an internal API to their external users, and whoopsie daisy, they just started exposing PII in some of those responses as well. So those are the types of things that are very quickly discovered by attackers, very quickly exploited, and development teams, security teams need to be on top of being able to discover that. So as soon as you see that type of data coming across, that's a red flag. We got to shut that thing down, and we got to try to get that off there. So those are some of the earliest things that you can do from a discovery perspective when you look at things in production. Now, as you move further back into the actual pipelines itself and you start working with your dev teams, that's when you start actually going in, checking in that specification. So don't make your developers write the whole entire specification from scratch. Bootstrap it for them. Give them the starting point for it. Let them start to manage it from there. As they start to get good at managing that and making sure that everything's up to date, the great thing that you can do is you can then start actually helping them with their test cases. So by building out fuzz test cases based on your specifications, by building out some of your actual test pipelines in here, you can start to more proactively identify and discover some of these security vulnerabilities up front. So this is the way that we recommend that you actually go and realistically deploy this type of framework. Ultimately, what we've seen is just starting at the build phase means that you're going to get stuck with individual teams, especially when you try to scale it across 300 different development teams. By kind of taking more of this, start in what's in production, work your way backwards and back to production again, it provides a holistic life cycle and way for you to be able to get there. Now, as we look at the different mechanisms that you have for deploying this type of technology, ultimately, the first and foremost thing is everything that you're exposing out to the internet, protect that stuff out at the edge. I mean, that is the number one thing you always want to start with, especially for API security. Start with all of your public-facing APIs. They are going to be your biggest threat surface, the biggest attack surface for a lot of the organizations, and so ultimately, that's going to be where you start. But as you start thinking about things a little bit further into the future, that's where you start needing to look towards your internal APIs and everything that you have there as well. So we talk a lot about east-west traffic as you're starting to look at more of the internal picture, and especially for organizations that are adopting technologies like GraphQL or specifications like GraphQL to be able to change data. Ultimately, what that ends up doing is that provides a really robust interface for not only your developers, but also for attackers to go and start looking for data. And so what we're seeing more and more is as organizations are becoming keen to that type of attack vector, they're starting to deploy more technologies directly behind the firewall as well, and kind of classic edge perimeter use cases in there. And there's a whole bunch of different ways that you can go and do that now, which is pretty cool. You can do things at the ingress controller if you're running Kubernetes. You can do deployment-based and using just standard traffic capture and PCAPs and things like that you would kind of look at more holistically. We can do Envoy integrations. You can do Lambda layers. There's all sorts of new integration points, which is really, really helpful because no two architectures, especially in a cloud-native world, are the same. So having that flexibility to start looking at that traffic and really gaining a handle on it is truly what's important there. So that's it for me right now. I just wanted to say once again, it's just been a pleasure here to actually be able to speak to everyone in person and be able to see faces and not just talking to my dog again. We have a booth, we're like over in the middle there, over at 205. What's most important is you can come over, you can ask us any other questions, anything that we didn't have there, but even better, we've got ice cream over there. So after you get lunch, go get ice cream. It's really, really good. We've got tons of great swag and everything else, but we'll be able to happily answer any of your questions that you have around API security. And I think I got a couple more minutes, so if anyone has any questions, I can go ahead and take those too right now. Yep. I'll meet up with you afterwards.
Let me ask it, and then you can maybe repeat it.
Sure.
So you talked about kind of inspecting payloads both at, hey, there we go.
Oh, perfect.
So you talked about inspecting payloads both on the way in and on the way out.
Yep.
For potentially sensitive data that might be sent out in the response payload.
Yep.
Do you often find that there is a mismatch between what a developer expects is going to go out and what actually goes out?
Yes, frequently is probably the best thing. I think there's two areas where this really kind of comes into play. APIs as a whole tend to be additive in nature. And so we never really see things change in the sense of like payloads get or parameters or response data gets taken away, but a lot of stuff will commonly get added to it. In particular, I think where it becomes more of a problem is if you have a developer that is basically saying, well, we have one service at the edge, and it's basically going and talking to another service, and it's pretty much just taking the response of that and then shoveling it back out to the user. That's where you start to see some of this creep come in. And so it might not even be that the developer added something explicitly. It might have been another developer further down the chain that runs service B that added some parameters, and then service B is now exposing it to service A, and service A was just turning around and sending it right back. It's kind of the equivalent of, in like if you're writing SQL queries, where you might say select star from, a specific table, and then if new parameters or new columns are added to that database table, that shows up now in the response. And that's pretty much exactly what happens with APIs as well. Yeah. Any other questions? How do you discover it? Yep. So the way that you end up having to do discovery is usually you have to have something that's going to be in line. You have to be in the traffic path in some way, shape, or form, or you have to get a feed of that traffic from some other source. So in an instance where you are in line, like let's say you're using a WAF out at the edge and you're basically getting a feed from that, that's a really good way to be able to do it. Alternatively, if you do have things like Kong API Gateway is a really good example. Kong will actually allow you to plug in other instances where you can be able to get basically data feeds in there. It's kind of like a raw feed from it, or even some instances you can do log discovery. There's lots of different methods to do it. Ultimately, the biggest challenge is you need to be able to actually see the unencrypted payloads because that's where all the meat of it is. And then in other technologies, one thing that I didn't really get into details on, but can be a challenge is if you're dealing with other things like gRPC. gRPC is a common protocol that's used for a lot of microservice to microservice communications. You also need the ability to do things like deserialize protobufs. So there is some nuance and some detail, and every API will be a little bit different. But I would say probably for like 80 to 90% of the use cases, as long as you can capture that data out at the edge, you'll be good to go. All right, well, thank you. Oh, wait, you have one more question? Yes.
I do have one more if you got a minute for it. So you talked about signatures, and like you said, like I know kind of in the security community, that's like, oh, old school, very kind of antiquated pattern. But I kind of agree with you that there is validity in it. So I'm curious, like from an API perspective, like is a signature kind of source IP table stuff, like bad reputation IPs, or is it more kind of the structure of the query, or is it more what's in the payload? Like what is that signature that you're looking for?
Yeah, it's going to be more like what's in the payload itself. And so you can think of them a lot of times, like a really good example was like the Apache Struts vulnerability. It had some very specific parameters that was going after. It had some very specific payload context that it was looking at. And so it was pretty easy to write a signature that kind of locked it down. Log4j ended up being a little bit more difficult because even though the attack payload itself was relatively uniform, aside from all the permutations and variants that basically came out, the biggest challenge it had was it could really manifest itself in any HTTP header or any request body. You just didn't know how it was going to be used later on. And so those were some of the more challenging ones that you had to basically go and discover. But ultimately, it's a lot of regular expression pattern matching in those instances. You do use, multiple methods to be able to classify it. So, and only for certain types of attack payloads you want to do that. If you're dealing with bots, if you're dealing with other types, account takeover, you can't rely on that at all. You have to rely on different mechanisms.